Right, welcome everybody. How we doing? Welcome. Hey Glorious, good to see you. How have you been? What have you been up to? Right, let's open our temporary text editor. I want to see if I can quickly make it so I can press the F5 key and trigger a build. You know what I mean? Because that'd be super handy. Of course, done with a text file. Want to run a command in the terminal? You know what I could do? Yeah. Instead, run terminal command with shortcut. That's what I want. JSON file. You know, I can't bother with that. Right. It gives you more of an incentive just to get on with switching to the proper text editor that we want to use. Hey there, Travis. How you doing? Good to see you. Yeah, so I did some programming off stream, which I typically try not to do, but I just really wanted to get this range allocator done and out of the way. So I broke the rule. But it was just writing this test function. So it just goes over 4 times in this loop, generates a bunch of random indices in an indices array, and then does 512 lookups into the block structure. If it's been allocated, deallocate. If it's not been allocated, allocate it with a random number of nodes, and then validate the whole allocator to make sure all the state is valid. So it's just some unit test thing, and I run it and it works. So that's good. I'm pretty confident that the allocator is mostly bug free. I think there's probably a bug. There must be a bug when we fill up the allocator. I still probably got to test that, but I'm happy where it is right now. So yeah, it's mostly bug free. We can be kind of sure about that. So today's agenda is to write the BVH API. So that means you know, we construct one BVH right now, but it's just all hard-coded. We just run a set of shaders. What we want to do is be able to build a bounding volume hierarchy by feeding it an array of ellipsoids or something from the CPU or from the GPU. So we kind of want to build that API. But before we get started on that, I want to make a quick I want to change the BVH node structure and do something a little bit differently first. Yeah. So currently we do something kind of dumb. In our BVH node, which is 16 bytes, I store a root children count, which takes up 2 bits, right? If the node index is 0, and the rest of the nodes throughout the whole tree just waste 2 bits. And the reason why we do this is because we need to know the number of children for a bounding volume hierarchy at the root node, because if we run the code, we don't technically have a root node in the final BVH tree. I thought it would be a waste of... One, it's an extra level of indirection, and then it's a waste of 64 bytes. So I wanted to mainly to avoid the level of indirection. So we just have the root node sit at the start of the block of memory we allocate for the whole BVH. So as you can see, we have 2 children, 3 or 4 children, right? For the root node. And yeah, so we've got two options really. We could have these two as invalid and make it just always check the first 4 nodes. So these nodes could just be not invalid, they could be null, like zeroed maybe. And then that would mean, and maybe that's the way we do it. I just pasted a bunch of stuff in there. No, don't do that. Basically done asset packing. Now figuring out how I want to load it in one go without any parsing. Oh. So presumably your assets are compressed as well. So you want to put into memory, decompress it all, and then yeah. Well, what do you mean without any parsing? Because that assumes you've just got binary format. Maybe. Yeah. Thank you so much. Appreciate it. I'm glad you enjoyed the video. Yeah. Someone posted a comment on my live stream from Tuesday, the log on that, and they said, "Great stream." I was like, "Okay, someone's enjoying it. This is great." It just sort of, you know, somebody's finding it good, so that's great. I'm happy about that. But yeah, thank you, sir. Appreciate the compliment. Yeah. So I wonder, what should we do? Should we not bother having? Because then I won't have to pass them back to the CPU from the GPU ever. That'd be good. Maybe let's just see if we can do that. So we built the BVH. It should be quite good. Right. When we build the BVH in shader code, gotta figure out what my file thing is now. When we get to the root node, I guess, I forgot what it's in now. It's like pack quad. Alright. So here we say while we're not the root node. And then when we reach the root node, then it stores the number of children at the start. It's just really dumb. This is all debug code. I'll visualize the final one. But I think where do we do it, right? We do right, so we have the nodes here. So we could say based on the number of children, we could say 0 the rest of them. And if the rest of them are zeroed, then when you try and ray trace against it, you'll never hit it. That could literally be all we need to do. So you just do something like a for loop, where I just got a for range macro in this code base, I know. So I think we just do something like for, right, and then simply memset 0 the thing. You don't have memset on GPU, so we just do word 0 because it's just a bunch of words, right, where we've manually packed it. 2 and 3. So everything is null. That would be interesting. I wonder if we're gonna do something terrible by doing that. So in the ray tracer, we pass up a reference, BVH ref, base node, And it gets the children count from the first node and uses that silly function which we're now going to delete. But what if we just put 4 there? Right, and then search over the 4 children, and the 2 at the end are going to be zeros. Right. So hopefully, fingers crossed, this doesn't crash and burn the stream down. That would be good. I've got to compile it first. And here we go. Fingers crossed. Right, the stream is still alive. This seems good. So we're paying a little bit cost of runtime maybe. Every compute unit that starts at the root node, which is all of them, will check this node, and these 2 invisible nodes over here, right? Because there could be most of 4 children. But just for the root nodes, right? But the rest of them, will only check 2 of them. But it is done in a for loop, so theoretically it would check as many as are in a wave, right? And the other lanes would just be inactive. So it's okay. But yeah, we can move this around, it still works, and I don't see any problems with the rendering. Oh yeah, that's a glitch because it's basically a disk. It's quite funny though. Yeah, don't make perfectly flat ellipsoids. It's bad. Right, that's amazing. So that's changed how I thought about it earlier. That's cool. So that means we don't have to do it. Where is it? Lost it now. That to-do list. I don't think we need to read back a GPU ref from the GPU anymore, because the reason is because the GPU ref. So we allocate the BVH nodes on the CPU, and we tell it to build it on the GPU, but we don't know how many nodes there is going to be fully. We can just guess. We can know the maximum. But also we don't know how many nodes there is going to be on the root node until we've built it. So that was a big problem, because we needed to know how many children there are in the root nodes. We don't need to know that anymore, since we just say, hey, there's 4, and we've zeroed the rest of them if need be. Alright. So I think we actually will still need a bit of feedback, and that is, how many nodes did there end up being in the BVH tree at the end of it? Because then what we can do is we can free the memory back into the custom allocator that we wrote last stream. So that's going to be very useful, actually. So I'll keep that in mind, but I think let's go ahead and start writing the API, because I'm quite excited to do that, actually. I get to use my object pool again. And I like using an object pool. I planned fairly simple game. So I just want to do multi-threaded read syscall into pre-allocated memory for the game state and into mapped transfer memory for GPU textures, texture meshes, and be done with it. It's easy for textures, but can be trickier for game state. Yeah. Right. Hmm. I don't think I was remembering something. Yeah, that was it. I remember reading a Twitter post and someone was saying that they managed to mmap a file and you can give that to the graphics driver. So that's another possibility if you ever want to use mmap. But I don't know if there's benefits using mmap anyway, if you're just going to read the whole thing in. I think read is typically better for that, unless you're sharing it across multiple processes anyway. But yeah, it's crazy that the graphics driver supports that though. So what? But yeah, cool. It sounds into for game state, right? Yeah, yeah, like assets and stuff. Typically, you just have it saved on disk. Maybe, yeah, if you save like a BC file, like a block compressed file, put that right in, or just the plain old pixel data if you're that interested in doing that. Yeah, you could just zip compress the pixel data as well. Another way of doing it. But yeah, game state, I guess, is always a bit tricky, right? It's that problem where you have the serialization format, how it looks in the file. Then you have the sort of game logic side of how it looks. Then sometimes you have the network side of how that structure looks. And then sometimes you even have a render side of how that looks. And sometimes it's just better if it's simple enough to join them all up, because if not, you've got all these different data structures you've got to convert between. And that's more code, and yeah, just becomes the way, doesn't it? So BVH node allocator. Now let's make our BVH API. I need to get like a sound effect when I press the enter key, it goes. That'd be great. BVH. Yeah, let's call it BVH. What's wrong with that? So when we have a BVH, it's basically going to have a pointer to the allocation. And so here's our block that it's allocate from, so we can get the offset into the buffer and everything, which would be great. And I don't know what else we need. Oh, for crying out loud. Right. So for now, I'll just stick with that. I want to make sure I do a core define object pool. All some magic stuff going on. BVH ID. Yeah. So this is gonna, it's gonna generate an object pool so we can allocate and deallocate an entry into an array. Basically, it's just a superset of an array with some tracking stuff, and we can use a 32-bit integer to refer to it rather than a pointer. So it's an ID with a bit of some counter bits to the higher bits. So when we free some elements in the array, we can know if we're using the old handle or the old ID or not, right? Just basic stuff like that, really. So we're going to go ahead and define that in here. Core object pool BVH object pool. So now we're going to make our API, which is going to use this. So the API is, you get back a BVH ID, and you say BVH graphics BVH init, I guess. Is that what I did for my GPU stuff? Let's stay consistent. Yeah, so GPU buffer init, get back a resource ID, which is a similar thing. It's just an object pool of resources. So I'll keep with that one. We don't really know how big it is, I guess. We'll just stick void in there for a bit. the next thing to do is we want to be able to build bottom level, I guess. And from CPU, and I guess there'll be a from GPU one. So the from CPU is going to take in a bunch of ellipsoids. Now, I don't know. It should be shared. BVH build ellipsoid. Center position, half dims, rotation. So the thing is, right, this says norm and unorm. Yeah, I guess this is fine. Yes, this is fine because it's the local space of the object. And we're never going to use ellipsoids other than the local space of the object. So from CPU, we just pass in an array of ellipsoids. U16, right? So maximum number is 64K. So obviously we need to pass in the BVH ID. If not, how are we going to add it to it? Right? And then I think I want to do a from GP version. So this one is going to take in a buffer. Ellipsoids buffer ID. Do we need an offset? Maybe, because you could probably generate multiple builds within the same frame if you're feeling lucky. So ellipsoids offset into the buffer in or start index, make it more readable, and then the number of ellipsoids is the final one. But maybe you get the count from the buffer as well, because at the end of the day, then that's indirect, isn't it? And indirect is kind of great sometimes. Maybe we can do different versions. Hey, and Blamey. What's up? Yeah. I'm becoming a hipster normie now. You know, VS Code is too popular, so I've got to do the newer text editor, you know. But yeah, we're I basically rage quit from NeoVim. I updated my system, and it hosed my NeoVim thing. There was errors popping, and it looks like from various plugins. Either to do it was I don't think it was to do with the language server because I deleted that one first, and then I and I run it again, and tree it was still complaining. So then I deleted that, and then it resolved itself. But I tried to update my plugins. I tried all sorts. It seemed like I had to probably edit my config, and I couldn't be bothered to do that. So I decided to rage quit instead. Currently, we're using Z because people said it's an interesting one, so I thought I'd try it out at least. I'm not going to bother using it for long term though. I'm looking at switching to Helix because I'm now a Rust fanboy. No, jokes. Basically, Helix looks like a NeoVim that's kind of set up out of the box, but it's kind of also written with a fresh code base rather than just taking the Vim code base and then, you know, adding a bunch of stuff to it. It's all written from the ground up and has a language server protocol built in. It has tree sitter built in. It's built by the no, it isn't. Sorry, that's Z. Z is built by a person who made tree sitter, and Z is also built by the person who made Atom. So those two people are doing that one. This one is made by some Rust people, I guess. I guess they're both written in Rust. Rust all the way. Yeah, no Electron, no Vim script, no JavaScript. This is the key seller about it. The config file is a config file. It's not a programming language. So I'm interested in trying this out. People are using it saying it's pretty great, I want to give this a good go. But I still have to set up a config file because I've remapped all of my keys. I'm probably going to remap all my keys again in this. Well, no, I am definitely. But I probably want to do it again from scratch. And I think I want to figure out like I want to relearn a new key layout, which is even more effective than my current one. Yeah, and go full ham using this. That is my plan. But for now, we are just getting a feel for Z. I'm not going to get more of a feel than a basic user though, because I'm not bothering customizing it at all, really. BVH stands for Bounding Volume Hierarchy. How's it so far? You know, the out of the box experience is great. I installed it at the beginning of a stream, last stream I think, and it just worked out of the box. Language server protocol, you know. I can feel there's already kind of some limiting things with it. But again, I've not bothered diving to. It does feel a bit bare in some places, shall I say? But it's got a lot here considering how new it is, and it's impressive what they've got, and you know how stable it is as well. But yeah, it's early days, so I can't complain much about it. Definitely needs a bit more polish in places though, but it's impressive where they're at. I probably would recommend it to people if they want to try a different editor. They're into non-modal editors, modeless editors, you know, standard text editors, because it's snappy and it's got all the sort of new features. It's even got Copilot in here if you're into that. I'm not really into that. And it's built to be some multiplayer editor, so I don't know if I really want that, but it's there. A daily drive Helix, pretty nice to be honest, and yeah, it works out of the box, no mess around with almost anything. The different style of editing takes me getting used to. Yeah, because they do the selection before action, isn't it? Yeah, I don't think I was too happy that was the default, but I think also it probably doesn't matter. It's just, yeah. But I would rather not die on that hill. I think the rest of it is quite. I'm really happy with the rest of it to overlook that, I think. Mono software written in compiled languages, the past has been recovered. Exactly. Yeah. It is a shame how most things have gone. You know, Electron crap. But you know, even if they're not Electron crap, they're probably some C# crap. And you know, that's some, or Java, right? And then people are like, yeah, but C#'s ahead of time. It compiles when you boot up your Windows operating system. You see it all compiled in there. So yeah, that's dumb. Or rather, it can be compiled when when the program makes it. Programmer makes it, you know. Yeah, Z does have a Vim mode, but Vim mode, I have two problems with Vim mode. One, they're never usually fully a full solution. Two, the editor is not built around modal editing. I'm a person who really likes the full modal experience. I like, you know, I don't like this. I don't like, I want a full screen of text. I want keyboard shortcuts to do everything, like in which are just one key press away or a couple, right? And if Vim mode's an afterthought, you've already lost. You've already lost, basically. Yeah, that's my 2 cents on that one. Right, so after we get some feedback from the GPU, we also want to be able to be like, oh yeah, by the way, We also want to say BVH. We want to be able to take back the allocation, and it's just going to be like one function call actually, but I don't know. Shrink to fit. From the feedback, only used with the feedback from the GPU. Right. And then we also want another kind of internal bit of API, which is it's just a get, and it just derefs on the ID, if you get what I mean, right? Takes the ID, gets back a pointer, boom. So I think this is where we want to start today, and go full ham on that one. So what? Do you know when 80 columns was invented? Do you know how square the monitor was when that was invented? I guess we need a D in it as well, because otherwise what's the point of using a pool? Might as well just use an array. Alright, so this is just shortcut code for not having to remember the exact function. What do I know up here? Alloc BVH, and then remember the exact place where the global is, but instead we can simply you know, what this does is it returns the BVH pointer, so it allows you to fill references. Allows you to fill in the data, but it's zeroed by default, so I don't have to do anything, because that's the way the object pool works. It's amazing, but in future we want to fill in some other defaults. We can do that too, or initialize it in other ways. We can also do that, but that'll do for now. Cool. So, this is D in it. D. So D in it. Pass in the ID called DAlloc, and voila. Right, and then the final one, which kind of uses this object pool APIs, is the getter. So we just do get as a get, and voila. Wait, we'll do return. This is not Rust. And then now we can use this guy and make our life a bit easier in places. So we get the BVH. So build from CPU, build from GPU. So I think we generally want like an internal function which does build from maybe build from CPU. That's a bit of a confusing name. Build from CPU data. GPU data. I think that makes, because build from CPU someone could misinterpret that as, hey, it's building the BVH on the CPU, not the GPU. So that kind of helps. So I think ultimately this one wants to call the GPU one, right? And it wants to, so the ellipsoid buffer is going to be the G build. Oh shoot, there's an indices buffer as well, isn't there? Wait, but the indices buffer is what again? Why do we have that? That's for sorting, isn't it? Yeah, what did we even do with that one, by the way? Okay, I think I need a function which, I need a new shader which just generates an incrementing list of indices. Yeah. Right, we'll get to that. So what we can do is we can bump allocate into this ellipsoid buffer, and then so start index equals ggfx. So we want to be able to say like next index or something like this, and then we'll put the start index in there, and then the number of ellipsoids just goes in there like this one. So yeah, that'll bump. Now we also want to know if there's kind of room enough room. Obviously, I'm not quite serious. I don't know, maybe. There's people around. I've had some strange opinions in my life. And I probably believe some of them as well. But yeah, hey there, Anze. How are you? Welcome to the stream, sir. So I think we want to return a boolean to say like, oh, did this thing actually get built? Because we can safely check this, I think, right? When we build the there's a certain number of like max leaves, BVH leaves. Yeah, you know. Yeah, so I think what we might want to do is say like, oh, this is the maximum number of build leaves. And for now, we'll just stick it to the maximum number of leaves in a BVH. Or maybe we can say, maybe we support up to, let's just say we support up to doing like 64 builds, right? This could be a bit of fun. So, yeah, so when it comes to doing more on codes and all this, sweet, we've got leaves capacity, neat. So, right, looking promising. Yeah, so what we can do is we can say, right, end index equal start index plus ellipsoids count. Now, if end index is greater than or equal greater than the number of leaves in the buffer supports, then just return false. And then here we'll return true. So yeah, that's interesting. I like that change. Ooh. Right. Then if not, this thing is equal to end index. Right, so we need to make this a thing, proper thing. So this is the next allocation. Put it next to the buffer. It should get zeroed. Yeah, it gets zeroed because it's global. But every frame it needs to be reset. So we need to make sure that we do that before we go and do anything else. Render frame. So one of the first things we can do is just reset that. Neat. So how does that look like for a CPU build from CPU side data? Well, we didn't actually upload anything into it, did we? So, you know, right now we're just saying, oh, it's in there, but we didn't put it in there. So to do that, what we need to do is say, right, GPU upload to the buffer. What I'd like to do is upload to GFX BVH ellipsoids buffer. What is the offset in bytes? Well, the offset in bytes you see is start index multiplied by size of BVH build ellipsoid. So I could also just do deref of ellipsoids. That's another way of doing it. And then the size in bytes, then I'll copy in. So that is very similar, ellipsoids count multiplied by size of deref of ellipsoids. Now, that's going to get me a super lovely place to throw my nodes in. I'll throw my ellipsoids in. So all I do is just say copy me some elements, many of them please, into destination. Source is ellipsoids, and ellipsoids count is the number of ellipsoids. That just as a mem copy with the multipliers by size of automatically. So upload to GPU, and then call into the from GPU data one, and then here we can do that. So what happens if we generate a BVH on the GPU? Is that a thing we would ever want to do? Because if we did, the ellipsoids count would be kind of important. Yeah, we think about that one. I'm saving the heavy guns for when you know me better. I went through the Vulkan VODs you gave me last time I was here before. Learned a lot. Awesome. Glad you learned some stuff. I'm glad that helped you. Or the use Rust, the live variant. Yes. Yeah, I wonder if people will see a bunch of people come off Rust. Probably would. If there's like a new language or something. Right, so ellipsoids count. Ellipsoids count. This can come from the GPU if we want to do that? Do we want to do a version for that? So like, is there going to be a point when I'm ever going to generate a bottom level BVH, so a bunch of ellipsoids, or a bunch of instances for top level on the GPU? I don't think I see myself doing that for this game. So I don't think we'll do it. But maybe we could have our ellipsoids already on the GPU because they get animated every frame, and maybe it's so small you can Yeah, but that would just be refitting, wouldn't it? Hang on a minute. What did I just do? Yeah, these should be called build. I might wrap this since we're going around and yeah, actually BVH build and then like ellipsoids buffer. I think that'll make more sense. So specifically to do with building. Oh, my music. Oh. Let's just go into the next song. So this would be rather interesting, I reckon. So we have BVH build, the molten code buffers, the ellipsoid buffers. And then I think we need one. Yeah, and this next ID thing, next index thing. Right, I think that's really nice. Go to that comment because it's pretty dumb now. BVH build. Right. The allocator can kind of be out of that, I think. Because it's kind of it's not just for building. Right, that is specifically for building. Cool. So we talk about like BVH build dot right ellipsoids buffer. Yeah, I know that. It's pretty sweet. I like it. Oh yeah, this is all wrong as well. Ding. Oh. Right. I think I'm happy with that one. So the next thing we would like to do is make this work. So from GPU data. So we're going to go ahead and find where that molten code stuff is. Yeah, this is it. Stuff that builds the tree. That's all the irradiance map stuff. We ignore that. Let's take all this. We've got to be super careful now not to run the code because it'll just crash and burn everything. GPU data. Right. Let's get in there. So I guess I've not handled for a tree is 1. Like a single leaf node, I think. So a future version of me is going to solve this problem. That is not present Henry. Future Henry can solve that one. And I'll keep passing it to future Henry until it's time. It's a shame that we probably all need to learn Rust though, because some core tooling is going to be built in it. Italy working with grass and trees is actually a strength of it. Is working with graph and trees a strength of Rust? Because I thought the whole point of Rust is you can only have one mutable pointer or reference. So trees are actually quite annoying with it. You have to basically turn them into indices, and then use indices instead. Whereas in C you could just use pointers and stuff, right? So I don't know. I wouldn't call that a strength. Like in C, I would probably do a lot of things with indices though, but I opt into doing it that way. Yeah, I don't know. Learning Rust isn't too hard. I picked it up pretty easy. I guess you can get people who are really into their generics and stuff, and put in explicit lifetimes everywhere, and things just look already difficult to program. But you're going to get that in any language. So I wouldn't really say that. Yeah, I think it'll be fine. Oh yeah, create iterators. Yeah, you gotta chain them all together, and yeah, I forget about the iterators. Oh man, I'm drinking here. Well, let me just shoot upstairs and get a drink. I'll get my drink. Hey Davros, how you doing, sir? How you been? Rightio. So I think I remember there's an ellipsoid indices buffer. Now we need that to exist. So I think we need to make a new shader, and this shader is going to be called. So I've already got one specialized. Yeah. We'll just call it, ellipsoid indices buffer. I guess we can call it leaf node indices buffer instead, because it'll probably work for. Oh no. Right. So we want to fill. An incrementing. Yeah, set of indices, whatever you want to call that. What is that even called in maths? Does anyone know? What is this called when it's like 0, 1, 2, 3, 4, 5, 6? Like, we just want to make a shader that does that. Like, does anyone know what that is? What you'd name that? Like a set? Just, incrementing set of numbers? Arithmetic progression. That sounds like it does work. Arithmetic progression. Right. I got a name. Arithmetic progression. Progressioner. Okay. There we go. Destination buffer ID. Contrast with geometric progression, right? Not the language itself, but the tooling available, you can't do it directly. Been practicing Blender a bit more, been making a few more enemies. Awesome. Yeah, I remember trying to pick up Blender and stuff. It seems, it's one of those things where the tool is so complicated, so many little menus and things. But when you really get into it, yeah, I could see myself getting into it and learning it. It did seem quite fun. But yeah, you just have to put the time in for it. Because they also release new updates and they change the UI and all this. But yeah, it does seem fun. I just starting to miss the immediacy of C. You can do absolutely anything with for loops, raw pointers, struts. Yeah, definitely. Unsafe. Sequence. Or linear sequence. Right. Yes. Yeah. Hmm. Yeah. Sequence has to sound better. Yeah, linear sequencer. Yeah. Hmm. Right. Gen linear sequence. Right. This is fine. E32 number of elements count. Alright. I think that'll do. So we just need to make a nice shader. Right. Super nice shader that just literally does one thing. Destination buffer. Buffer. Index. Ta-da! Oh, I gotta name it properly. Right, legit. So yeah, I think I want to be careful. It can only be so big. I might have to start doing a 2D one because I think you can only have 65k, sorry, 64k groups. So 64k times 32 number of elements along one axis. But that's where you need a y-axis and then flatten it out. It should be alright. So here we're just going to do something like this. So destination buffer is going to be the BVH build indices buffer, right? We're just going to make a linear set of those boys and girls. Yep, number of ellipsoids. Read write on that, please. Gonna make sure we launch the right shader. I've done that before, called the wrong shader and then cried afterwards. Yeah, I think that all looks fine. So that's going to create a linear sequence of indices that we can then sort later. Well, we saw right here, right? We're actually sorting the Morton codes. Crap. We now need to get the Morton codes in there. Morton codes. Yeah, I think I'll write a shader called Morton. Generate Morton codes. Right, it's another one. But how are you going to read the position in that? Because it's in like... Or the... We could equally just upload it from the CPU, but then we got this GPU one. So I guess you put the mortal codes in another buffer somehow. Because if you're writing out the ellipsoids on the GPU, you can also then just write out the... Or... Yeah, I don't know what's quicker to... Yeah, it's probably quicker to generate them. Yeah, let's try generate shader. I'm happy with that. So BVH ellipsoid Morton code. Generate ellipsoid Morton code. What? Ellipsoid Morton codes. So you got destination buffer, the Morton codes go, they're just 32-bit ints. Then you have your BVH build ellipsoid. And there's your source buffer, I guess. The number of ellipsoids. And Morton codes, obviously, because they're parallel arrays. So the basic idea is you need that Morton code function somewhere. Did I put that somewhere sensible? More 3D. Oh, it's in the shared file already. Amazing. So I put in a 3D coordinate and kabam. So, right, let's get in there. So more code 3D. So we just do BC source buffer index dot position. I think that's what it's called. I don't know. Build ellipsoid. Oh, center pause. Right, of course it's called that. Right. Yeah, so that will take this 3D vector, convert it to a 32-bit integer, where all the bits are interleaved. So the X, Y, and Z bits are all interleaved. So we need that shader as well. So let's go and dispatch that shader. So we copy paste this one. Let's make sure we get this right. We also want to, so we want the Morton codes. Morton code ununiquified buffer. So before unification. Then source buffer is the ellipsoids that got passed in through the function. So we write to that one and we read to this one. You know, part of me should have just thinking about it now, I should have, these functions should have just returned what this function returns, and I just do it all in one line. But, yeah, because this is just kind of dumb having to write it twice and maintain that. That's rather silly. Yeah. But oh well. Yeah, Blend's UI is not nice, but improved massively over the past decade. Yep. Yeah, you just gotta learn where all the 7,000 things are. Like, it definitely looks good now. Like, yeah, they hide things in like little nooks and crannies. Right, I think that's good. Yeah, part of me just wants to make that change now. Yeah, part of me just wants to like, oh shoot, where are you at? Return GPU resource ID index. So just like, that'd be sweet. Not gonna lie. That'll make the code a lot less silly. So I'll just be able to do this, right? Now I have to look in two places and get those out of sync. Oh. Amazing. Why didn't I do that earlier? Yeah, and cool. So you would then read write, read only. Now, right, let's quickly change all these around, and then we'll be read write on the global buffer there. Yeah, we never touch globals in the other ones. We'll correct all the names of them in a minute. Neat. Right, that's definitely cleared that up. Nice. Right, so we generate the Morton codes. Now we sort the Morton codes. And then we sort the indices along. So these are the sort keys, these are the sort values. So now we then memset the uniqueified buffer and then uniqueify. Right, so we need to do a thing where we can search for this and then ggfx dot bvh underscore build dot. Right, and then we can do off replace. We'll just keep doing that until the end. Some of them are going to be a bit off, but that's okay. Right, so this build nodes one is just nodes buffer ID now, which is good. Except this one is just BVH nodes buffer, not BVH build nodes buffer. Right, so let's just double check and make sure that's all good. We didn't do a get for some reason. I don't know why we've not done that on this. So that's currently unused. There's like a start index as well into the buffer, which is kind of interesting. So we need to fit this in somewhere, because right now we've just read from the start of the array. So I think in this shader we actually need a source start index. And that'll just be ellipsoid start index. So when we actually write the code, the shader code, it would just be plus this other little like offset here, which is super cheap because this is just in an SGPR anyway. So it's already, it's not like it's reading it from a buffer somewhere. Alright, now we still got to fit in this start offset in places, so let's just double check, make sure things are all good. So this is all fine when we uniqueify the Morton codes. When we build the BVH, we do not reference the ellipsoids directly. Yeah, we don't reference the ellipsoids directly. So we build a binary BVH. Then we build the quad BVH. So a wider BVH by mutating the binary one. And then this one uses the ellipsoids buffer. Now, ellipsoids buffer. What does that mean? Well, it was this one is referencing the one globally rather than the one we passed into the function. So finally it gets to do it here. And then, but we also want to provide some form of offset, I think. So this actually builds the final BVH tree into BVH nodes rather than the build nodes. So the build nodes just builds like a temporary tree, and we can mutate it, and the BVH node is a packed version which is optimized for traversal. So we're going to have a build ellipsoids start index, so we can have multiple of those boys and girls. So there we go. Right, so ellipsoid start index. Ding. We've obviously got to use it in the shader, because if not, it would do nothing. So that's in the pack shader, pack quad tree. So where we reference, right, there's two places where it's done. One is in the commented out code. But yeah, so you'd do like BVH build ellipsoid start index plus that. And then down here, where we do some more debugging code that's commented out, I just want to make sure that's all safe. And then we're good. Right, so that should... That should be, yeah, that should be that done, I think. We've got to get feedback so we can do the shrink to fit stuff. So what's interesting is we now know how many, there's a number, right? We now know how many nodes, because we bump allocate the nodes. Where is that? Here it is, next BVH node index. So we bump allocate 4 nodes at a time. And this final number is when we know, where does it get reset? So reset at the start of a frame. Wait, if it restarts at the start of a frame, but it does it in the BVH tree build anyway, for the root node, reset for this thing, for the build quad tree. I don't think we need it here anymore. And that also means we don't need it. Oh yeah. So it builds the binary tree, then it builds the quad tree, and then allocates where the packed nodes go in the end. So all that means is we need to build a shader which will extract that number out and put it in a place for feedback. So I think we should... Oh wait. Yeah, I'm skipping ahead a little bit. To do allocate. Guess what we built last stream? An allocator. So this is where the fun begins. BVH block. Right, we have a BVH block. Deallocate it. So we're gonna go ahead and do like a BVH node range deallocate ggfx dot. Wait, let me think about this. Right, it's okay, I'm not gonna use it too much. I was thinking maybe we can get rid of this parameter because I only think I'm gonna have one instance of it, but I'm only gonna probably write lines like this a few more times anyway, so I don't know. Right, free the block, and then I guess, you know, we'll set it to null, but really we probably didn't have to do that. BVH node, you know, just get in there like that. Alloc. I don't understand why they write stuff like this. So in the Z editor, right, if I hold control and press delete, I'm saying delete a whole bunch of characters for me to the right hand side, but it deletes all the way up to the nearest symbol, not the white space first. To me, that's such a bad default. Like, why would you do that? Like, otherwise I've got to manually press delete. That's just weird. I could probably change it in the settings, but I'm not here for too long. Right, what's the number of ellipsoids that I need? Well, so for a quad tree, we need to do a bit of maths. Is that maths in a nice place? Well, it's not probably going to be done much. There's a bit of maths. Maths. Oh. Did I delete the maths? I think I deleted it. Well, that's ain't good. One does not simply delete math. No. I remember it though. Bloody annoying. Is that +3 take 1? Yeah. Right, let's write out again. So this is like our... So really what we want is we want like a function which says, given a number of nodes, can I get an estimate? So BVH, can I get a rough guess? Max. Allocation size. Allocation count. Calculate max allocation count. or calculate upper allocation count. So given a number of leaf nodes, can I get that please? So it's quite easy. For a binary tree, for a BVH, it is simply leaves count, take 1. That gives you the number of internal nodes. Then you plus the number of leaf nodes, and voila. But we're doing up to 4 children. So I need to do a round up. So I want to add 3 because there's 4 children. Then I do a divide by 4. Wait, divide by 3. Crap, this is where I need to... it's divide by 3, I think. And that'll give me the number of internal nodes. So... right, we can work this out quite easily. So if you have... so 4 nodes, you just have 1 internal node, right? So that's 4 plus 3 plus... I'll take 1, so that's 6. Divide by 3 plus the number of leaves, 4. 6 nodes. Something is off. That's not right, is it? So 4 leaf nodes plus 3. Take 1. Oh, I did do that. Yeah, take 1. Then 6. 2. And then, how's that 6? Oh, that's wrong. Maybe it is a divide by 4. Oh, yeah, it is a divide by 4. So 6 divided by 4. Round down to 1. And 1 plus 4 equals 5. Yep, that's right. So when you have 8 nodes, you have you have 4 children under the root node and 8 leaf nodes, 4 children under the root node and 4 children. Yeah, but they could be balanced in different ways, isn't it? Oh, that's interesting. You know what we could do is the U16 is the maximum number of nodes in a tree. So I guess you can have more than that when you build it, but when you're finished, better have that many nodes. So when you try and ask, so this would be probably the minimum, I guess. But yeah, so let's rerun that number again. So it's 8 plus 3, 8 leaf nodes plus 3. Take 1, which would be 10. Then divide by 4. Then there's 2, because it's round down. Well, it's round up, but we've already done the round up by adding 3. Then plus what? It was 8, wasn't it, originally? That's 10. So you got 1 root node, 4 children, which makes 10. Which makes 5, sorry, then plus another 4, that's 9. That feels off. Let's draw it so we're not just playing imaginary pictures. So you have one root node, 4 children. Then another 4 children under here. Oh, wait a minute. My brain. That thought of it wrong. So I said 8 leaf nodes. Well, in terms of leaves, you got 4 there. Right, and then 3 here. So if you have 8 leaf nodes, you probably need something like that at least. Yes, there's 5, 6, 7, oh. Oh, what did I just do? I didn't do anything there, did I? 8. There we go. That's 8. Until that's how many nodes? You got 3, 6, plus 4. And then plus another one, so that's 11. Something is wrong. Right, so 8 leaf nodes plus 3 take 1. Then divide by 4. That's 2. Plus 8 is 10, but we're seeing 11 nodes, right? Oh wait. I'm not including the root node, am I, in my calculation? Maybe that's fine. Let's see. So that is correct, right? We've got 6 there plus 4. Now, but we did just try it with 4 nodes, and it kind of didn't work out. Right, then did it. So plus 3, take 1, followed by a divide by 4, round down to 1 plus 4 nodes, which gives you 5 nodes. So yeah, this ain't right. Maybe I got this the wrong way around. Maybe it's plus 3 divided by 4, take 1 afterwards. Let's try that. So 4 plus 3 divided by 4. So that's just a rounded up division. So we get 1 from that. Then we take 1, get 0. Then we add 4 and then get 4. So that seems like it's worked out fine. Because we don't include the root node in our final number. But let's try 8 nodes. So it's plus 3. Ah, shoot. 8 plus 3, 11. Divide by 4. Round down to the nearest number. Right, that would have maybe been 1 if we didn't do that plus 3. Then we do take 1. Then plus the number of leaves, which was 8, wasn't it? It's wrong. No. So maybe it is that divide by 3. I'm a bit confused. But then that means it's a bit too much. So let's try again. 4 plus 3. Yeah, then take 1 will give you 1. Then plus 4 will give you 5. That's correct if you want to do it including the root node. Let's try the other example. Plus 3, divide by 3. Oh shoot. Right, 11 divided by 3. Take 1. So that'll be 2. Then plus 8 is 10. That's still wrong. Right, because the other one included the root node, whereas this one doesn't apparently. Damn it, why did I delete that code? Although I think it could have been wrong, because I swear I remembered it. But let's git log the, or let's git diff, can we do like on maybe a specific file? I want to do it on like source, shared header. Right, here it is. Take 1 plus 3. Minus 3. That's the same as what we wrote before. We just had it the other way around, right? We did. That doesn't change anything. Swapping that around does not change anything, right? Maybe it needs to be plus 2. Do round up. Let's try it out. Minus 1. Gives you 5, divide by 3. Round down to 1. So you plus 4. Number of leaf nodes gets you 5 nodes. That's fine. Let's try the 8 one again. 8 minus 1 plus 2. So it's below just adding 1. Divide by 3 gets you 3. Add leaf nodes, which was what again? It was 8. 11. Perfect. So that's what we want. So I can just make that add 1 to simplify it. So let's try it again with different ones. So as you reach a 5th node, add 1, divide by 3, plus 5 leaf nodes. That gets you 7. Does that make sense? 7 full nodes. So you got 5 leaves. So wait, that was already it, wasn't it? Yeah, 1, 2, 3, 4, 5. So how many is that? 7. 6, 7, 8. It's off by 1. We probably need to add another number. Oh, well, for Windows, you want a stable release? Why isn't the Windows one stable? Like, what's the problem? Is it their platform layer or something? Like, why would it be? Yeah, why would it be? So it's a bit strange. How's it going, Cat? The 5 nodes plus 2 divide by 3. So that's 2 plus 5. It's still 7. Still 7, man. Let's try it with plus 3. 5 plus 3 divided by 3. It still can't be plus 4, right? Because that will just mess up everything. Um, right, so 5 plus 4 divided by 3 plus 5 nodes gets us 8. That's the number we're looking for, but I don't know if I've messed up the rest of them now. That's correct, right? So you've got 5 leaf nodes, 1, 2, 3, 4, 5, and you've got 6, 7, 8 overall nodes. So let's try that again. With 4 plus 4, divide by 3, round down to 2, plus 4 gets us 6. That's wrong. So is it plus, it can't, that's why I already tried that. There's maybe a take 1 that's missing somewhere. Five plus 3 divided by 4. Aim right. That's still aim right. Like, right, for now, I'm not going to bother messing with this. I'll figure this out later. It's just so for now, we're just going to be like, oh, the maximum number of nodes you're going to need. Well, we've already got that as a number. It's just 64k, isn't it? So we'll just have a node. I think it's called nodes cap. We'll just use that. I want to crack on. There's other problems with this as well. The other issues include whenever you have at least 2 nodes, there's also 2 more nodes that are allocated to the side of it. Because obviously you can't have one child node. That doesn't make sense, right? You might as well just have this node, right? The parent node. But whenever you have 2 children, yeah, you can only have children when you have 2. There's always going to be at least 2 more allocated afterwards. So we're going to have to include that in this upper allocation thing. But the basic idea, so we can finish this thing off. Core unused leaves count. Good. Just got home. Awesome. How was your day? How was your work day? What'd you get up to? So we've got this calculate upper allocation count. What we can do when we say, hey, build from GPU data. Ooh, yeah. Build from GPU data. we're literally going to pass in given a number of ellipsoids, it's going to calculate some upper allocation count, and we'll allocate that from the block. Now, if it fails, it's going to return where there's an allocation, there's an assert. Yeah, so for now we're going to assert. No. We can just return. We'll make future solve the problem. We all like doing that, right? Return a Boolean. And so we return Booleans for both building from CPU and GPU data, which is kind of nice, I guess. Right, so that allocates the block. So when you have the block, it means you also have the start index into the nodes array where the things go. So it's just as simple as returning true at the end. And then when we pack them here into the nodes buffer, all we do is we add another offset, BC BVH nodes start index, and we just say BVH block. Double D references. I rarely see these things, but here we go. Start. So we get the block, and we go to the start index there. Okay. Oh shoot. Oh, I've already got it here. Okay. Yeah, I guess it doesn't matter where he goes. Yeah, to do allocate and done. So I think we already used that in the shader. Let's just double check that pass Henry is not trying to kill me right now. Right, pack quad tree, and we're using it here, you see. Rightio. Looking good. Okay. So we should now be building the BVH on the GPU into the new allocated range, which is great. Wait, yeah, do they ever have debugger support actually? I just tried to click here. Do they set breakpoints? That'd be something cool to see as a debugger support in this. Not that I'm here to stay. Oh, this is the Z editor. Z or Z E D. I know he spoke like an American. Yeah, I imagine that's why people use VS Code as the debugger, yes. Probably the best one on Linux. Yeah. Right, so that builds a BVH. The other thing we want to be able to do is do a shrink to fit. This would be super nice. How will we do that? Well, we'll call BVH get. Ooh. And we want to manipulate the block. I don't think I've written this code yet. So we're going to go back into the allocator, which I thought I had every function, but obviously not. We do have a defrag function, which we haven't tested out. But we also want to write a new one. I'm going to call it shrink to fit, I guess. So it's going to create a free node, basically. And we'll pass in the new size. See, shrink to fit makes it seem like you already have a size, maybe. Yeah, maybe. We should just call it shrink. Shrink 2. Right, so that means inside the allocator. Shrink to a certain number of nodes. So I quickly want to see, do we validate this thing? Right, we don't call the validate function. I'll not quickly do that. At the bottom of render frame, I want to make sure that I think probably before we do a start frame start, I want to validate the whole allocator, and I guess this can be turned off if it becomes CPU intensive, but for now this will do. So I'll just do the assertions and make sure that the allocators, linked lists and things are all good. But I want to get back to run the shrink2 function. Should be quite easy. All you have to do is first of all set. So you get yourself a, wait, this should be U16. Yep. You just want to make sure that, you know, that core cert, that BVH node range allocator. What are we thinking about? Nodes count? Yeah, this one. Pass in the block pointer and make sure that is less than or equal to nodes count. And then we say block ID this has less nodes than the new shrinked nodes count. So we'll pass in block ID, I got to get that as well. U16 block ID, BVH node block. Index allocator block +1. So block ID yeah, I could call it olds. Old nodes count. Call it that. So put the old in there, then put the new one in there. So how do we do that? Well, first of all, we just go if old equal new, then we just return success, right? Nothing's changed. But so now we need to work out some form of difference. So this would be the free block nodes count, which we're going to create. And that is basically going from the old is bigger takes smaller, right? Now we need to make a new free block. So we've done this in a previous function, it's here. So away we go. Wait, why didn't this set the toggle bit? The TikTok bit? Why ain't it got no TikTok? Ah, the TikTok bit is set here. We use the TikTok bit to validate whether it's been found in the linked list by ticking it and talking it every other frame. every frame, I meant to say. But yeah, so TikTok bit is set, so it's good. So we get the number of, right, so it's block plus the new block size. The end is at the end, obviously. When it comes to link physically, it goes block. Yeah, points back to that block, and with this one, right. This is awfully like. Yeah, this is interesting. Maybe we should make it function, but you know what functions are like. Yeah, shrink the block. It should. You know what? This should just call this one. Oh my days, I'm doing it. Functions. Shrink to. So you allocate a new block, and then get the one that's physically next to it in memory, or the place it's bookkeeping at least. Get that block, make it point back to the free block, else it's the end index, then shrink the block back. What's this? Yeah, then make it point to the free block. Yep. Just delete all that, and voila. So now we actually expose that as functionality. Yeah, so get the old size. We don't need this free blocks count because it's all done with start and end indices. Just make sure it's less. I didn't copy that. Those last two. Yes, allocate the free block. Starts after there and ends there. Points back to block ID. We don't have to call that again. Points to the next block in memory. It's not in the free list, but then it goes in the free list. Get the free block ID. If there's one next to it in memory, go to that, make it point back to the new free block. It just inserts it in between. And then if not, it's the end block in the whole heap of allocations. And then resize the actual block, make it end at where the free block starts, and then there you go. Cool, that's really great. So we've got the shrink to function now. Have I called it yet? No. So we're going to go ahead and search for shrink to because there's the BVH shrink to, and we're just going to basically say BVH block nodes count, and then it will shrink that down. We obviously need to take the address of GGFX node allocator, and voila. So that's a shrink to function that we can now plug into the feedback that we get back from the GPU when the BVH has built. So when the BVH has built, we need, I think the only piece of feedback we want is how much memory did it actually use, and then we'll shrink it. So that'll be a bit of fun. We'll do that later. but I've got a thing called a readback command buffer, which we could finally start using, and it's designed for this type of stuff. Is like have stuff that the GPU generates and send it back without having to write. But I could also just use the readback buffer. We'll see. Rightio. Should we try and get the system working then? So yeah, one thing that we haven't done is we need a way to turn this BVH ID into a this is the internal API. I want to have a way to turn this BVH into a reference. So in terms of a BVH ref, I really don't think. So then we need to redesign these things. So we had a thing called a BVH ref. It used to take a base node index, number of children, it had a depth in there as well. And it was kind of used as also a stack inside the shader code as well. I think I want to break it out into two things. I'm still going to have a BVH ref, but I think the BVH ref is just going to be maybe we can limit to a certain number of bits, and then we can just OR it on in places. So we'll just call it a base node index right now. That's always going to be aligned to 4 because we only allocate 4 nodes together in memory. So technically the 2 low bits are there to be used as well. So I think wrapping it in this thing might be helpful for later as well. And yes, this will be our BVH ref, but we'll probably add some bits in a bit or later. So the other thing I want to talk about is have like we only have so many registers on a GPU. They're called VGPRs, vector general purpose registers, and I want to try and have a stack of BVH nodes to go back to. But obviously so the VGPRs are typically 4 bytes, and I think you use 2 VGPRs if you have 8-byte values. There's also support for like half types as well, like 16-bit types. But you know, these things require extra features, and I'm trying not to use these extra features because I don't think I need them. So what we're going to do is create a thing called a BVH node reference. And these are going to be 16-byte values. 16-bit values, sorry, 2-byte values. Actually 16 bits. We only use 16 bits, so can be sort of so can be /packed to save VGPRs. Right. So I think the idea is so the reference is going to be some relative node index, and I guess we can just base node index, and it just returns itself, right? BVH ref. Does it have an uppercase thing like Control U? No, it doesn't. Okay. Sad face. Relative node index, and you can ask for that back, right? Relative node index. Yeah, it may seem a bit silly right now, but I guess it would be a bit of readability, and we can also change it in the future a bit. So here I'm obviously going to do and 0xFFF. So when it comes to using them in the shader, at least, we can pack them nicely. Okay, so now I've got this ref thing. Yeah, you can get ref back. So what is that? It's pretty simple. It's just an offset into the big old array of nodes. We just got one big array that we sub-allocate from. So we simply just do a get on one of these, and then return BVH block start. So just that start index, basically. Sweet. That's pretty nice. Right, so the next thing I'm going to do is actually take the code that we've been using to build that test BVH. Wait. No, all that test data that we've got, we're just going to plug that into this new BVH API that we've built. And then we're going to make sure that we upload it to the GPU correctly as well, the reference. And then we need to check on the shader. And then hopefully we can get that all up and running again today. So I'm just going to take a quick break and then we'll continue on that one. All right, welcome back, everybody. So, yeah, let's get using this API and see how it goes. Hopefully we have a very nice response from the computer that doesn't involve crashing and burning my whole machine. Right, we obviously need to create some form of BVH ID. for now. Yeah, so these BVH IDs will probably belong to some kind of like model or something, because you might have multiple BVHs for a model or something. I don't know. So they're going to go somewhere else. But for now, the easiest thing to do is put it globally. What am I trying to do? Yeah, I didn't. Yeah, I guess we'll just stick it in here. BVH ID, just some doesn't matter. So when you create, when you initialize the whole system, right, there's a bunch of this stuff that didn't get renamed, I remember now. BVH build dot. Neat. So here we'll just do a BVH. Well, one, we haven't created the actual system, have we? So we want to do a core object pool initialize address of ggfx dot bvh object pool. Static allocator. Right, static allocator. What's the capacity and number of BVHs? BVH trees. Capacity, that's it. So we've got our object pool initialized. Now we can simply do BVH init ggfx dot bvh id equals bvh init, and we just create a empty bvh. Now let's figure out where. So we'll just scroll past a bunch of test code for the BVH. Right. Render frame, gonna come up with more. This generates the tree, I think. Oh no, this was the PBR stuff, metalness, roughness, and that. All that UI, because I might want to bring that back, so I've just left it in there. This generates the actual array of nodes, right here. So, so we got the Morton codes in that in here as well. So randomly generates a bunch of ellipsoids, well, anywhere from 0 to 61, 1 to 64, depending on the slider. Well, sorry, 4 to 64. This was an implementation of the. Yeah, it actually builds it on the CPU as well. Yeah, I built it on the CPU just to test it, debug it. Using the same algorithm. And then we do the drawing of the nodes. And then here's where we do the upload of the Morton codes and things. Now I think this is where the fun begins. We can now say BVH. I forget my API already. BVH. So I guess that's an internal API, not gonna lie. Feels pretty internal to me. Right, I'll move it around in a second in the. But yeah, we want to build it from CPU data. And then we'll get back a little result. Res is a bit of a terrible name. So the idea is that you have the BVH ID. You also have the ellipsoids. That's just ellipsoids like that. Oh shoot, I'm glad we found this. We forgot this code in our shader. I'll move that there. Ellipsoids count. And Yeah, this is good. This is really good. So we got shaders now that generate more codes on the GPU, and we've got a shader which generates a linear sequence of indices in the shader, so we don't do that on CPU anymore. But I forgot this, right? So I need to look for more. It's in the shader, Morton 3D 30-bit. So we forgot this code here. I should already have a function which goes from unorm to snorm, right? And that sort of stuff, right? Well, this one is snorm to unorm. So -1 to 1 to 0 to 1. Right, I forgot that. Because this Morton 3D one, it takes floating point numbers. And then, right, my wife has called me. I'll hold this thought, BRB. Oh. Everything was fine. She just forgot I was streaming and just called me because she wanted to chat. But she'll be home soon, I think. Yeah, she was like, oh, you're streaming. I was like, okay, bye then. I was like, okay. Yeah, so what I was saying is this, it takes a 0 to 1 value, makes it 0 to 123 as an integer, and then interleaves all the bits, right? So it's x0, y0, z0, x1, y1, z1. And until you get all the bits and you've interleaved them into one integer. So my center position is in sign norm space, so I have to convert it to unorm. Alright, so I'm glad we found that, because that could have been painful. But anyway, it does this, and we're going to reset. I'm going to be like, the BVH failed to build. Sad face. It's not an assertive at sad face. So I think that's it. So that will then build that. Now, how do we know what's a ray trace against? Where's the ray trace? BVH ray tracer. It's got a BVH ref. So what we can do now is the to-do label. So we haven't got top level yet, but there'll be a top level at some point. But here we're going to go ahead and do BVH ref. And we pass in the BVH ID. And voila. So it's going to build it every frame. And then it will pass that in there. I do want to double check the shaders now. Alex, how's it going? Yeah, trying out Z. I'm only using it as a temporary stopgap because I'm going to move over to Helix. Because, yeah, I've decided to rage quit Neovan because it messed up when I updated my system and some extensions didn't work, and then I was trying to do the plugin updates, and then the plugin updates didn't do it. So I didn't want to mess around with my config anymore, and I wanted to look at other things. So I want to move over to Helix. I probably have time at the weekend to do this on Saturday maybe. So it's just got a bunch of stuff built in, and it's inspired by Vim, and maybe a newer Vim. But yeah, it's got a basic config file, and things are just generally set up better. It's got all the stuff you want: LSP, fuzzy find, tree sitter, and you can customize it. So I'm leaning into this and seeing how that will go. Oh, I tried Helix, but I could not get used to the key binding. The bindings, right. I did prefer Helix configuration to NeoVim, which generally prefers simple configuration, but not powerful. Right. Yeah, so this is why I haven't switched directly over to it yet, because I have a heavily customized Vim config. So I probably want to do another heavily customized. Sorry, let me rephrase that. I have a heavily customized NeoVim keyboard binding setup. So it's not default Vim in any way. So what I want to try and do is take that and redo it for Helix. But I think I want to maybe redo it from... I want to improve it even more and make it even more custom tailored to me. So yeah, I'll do that Saturday, and then I've actually got 3 days off the week after. Work is giving everyone 3 days off, 31st, 1st, and 2nd. I'm obviously busy with family on some of those days because I'm a family man now. But and maybe we'll get a bit of time to sit down and either set up Helix a bit more or at least try and learn it a bit more. Yeah, I think I'll probably much prefer the editor to any of him, to be honest. I see. I use default Vim bindings probably to determine, probably to my detriment, since I use the Nordic keyboard layout. Sometimes really inconvenient. Yeah. See, I use the Colmac keyboard layout, hence why I've already changed it, and it's all over the place. And the way that I thought about it, right, is the default Vim setup is not efficient on a standard keyboard anyway. It was kind of built for a different keyboard. Like you have to move your hand, like the default resting position for your key, the default touch typing resting position. You have to move your right hand over by one set of keys to do the arrow keys, and then move it back. It's just dumb. Like, so first thing I did was remap those to the resting position, and then I was just like, screw it, I'm gonna do the whole thing, and it just changed so much. But yeah. I've noticed about that aspects of Vim as well. It annoys me. Yeah, and like people just like use the default because it is the default, and sometimes it is useful if you're doing servers that you just download the latest, or put in a Vim and you don't really have much of a config, but I don't have that problem because I'm not a server guy. Hey, Psycode. Right, so let's go ahead and sort out the shader code. I've changed a few little things. BVH ray tracer. I want to try and do that wonderful packing thing, but I think I'll be changing too much. So, where's the BVH ref? Base node ID, alright. BVH ref. Did we? Aha, we kept it in the end. Sweet. Base node ID from the BVH ref. It does nothing, but whatever. So this is where we got the node ref. This is relative indices. So when we start this thing up, we start on the root node. Right, but you want to know the number of children you have, right? Because like... Now, since it's a relative node index, it means what? Yeah, you can probably store it in the low bits. Because... Yeah, so that'd be C, wouldn't it? You need two bits. So I think what we can do, right, is we can store the children, like, relative node index is always aligned to 4. So the first 2 bits are not going to get used in a number. So we should just be able to OR on those low bits there, and, you know, easy peasy. So you would just AND that. You don't have to do any shifting, you just literally AND it, because it's always aligned to 4. And then children count is again just literally ANDing a number. So that's pretty legit, I reckon. So for crying out loud. Yeah, so the relative index is 0, so point to the root, and there's 4 siblings. Should you say siblings? We're referring to count. Yeah, so child node's relative index, isn't it? Maybe you should call it relative children nodes relative. Yeah, children nodes relative index. Plop that in there like that. Right, it's better. So the thing is about referencing, yeah, it's only used to reference a range of child nodes. Hopefully we can keep it this way, because this will be legit. But I wonder how much VGPR space we're going to have, and for a whole, yeah. Yeah, I'm doing good, man. Yeah, things come along well. We literally just wrote the BVH API. So we've got a way to initialize and deinitialize a BVH from the object pool. So an object pool is just a superset of an array where it has tracking for every element, and it gives you back an ID, which is a 32-bit integer with a counter in the higher bits, so we can check if stuff an ID has been used after free or double freed. So I like having those, so I always get happy when I get to make them. And then get a BVH reference for the GPU. We've written the build bottom level BVH from CPU data and from GPU data, which has just been copying the hard-coded set of code for the example that we've been developing over the past couple of weeks, and putting it into a nice function. So the CPU one just gets the array of ellipsoids, puts them into some buffer, and then calls the build from GPU data. And then the GPU data one is going to go ahead and, yeah, we had to add a couple more shaders to make a linear sequence of indices and generate the more codes on the GPU. But the rest of the shaders that we have pretty much just got copied and pasted in there, and I've had to wire in a few things like use our node range allocator and wire that into the shaders so it offsets into the right array, or offsets into the array correctly to where the allocation is. So we should be able to build multiple BVHs. I'm literally just trying to figure out how do we oh shoot. Yeah, I'm just literally trying to get it all up and running again. Nearly there. I'm just fiddling about with some shader code, making sure I've not busted that. You don't have a depth anymore. Right. Yeah, so I don't have a depth anymore, so we'll just delete that. Max node depth, we'll just get rid of that. No biggie. So the only other place we've got to be concerned about is we insert into the stack. So node ref now. Children's start index and node count, node depth anymore. Neat. So I think that should literally work. I just got to get it all compiling. So let's do all that fun business. Right, so straight away, the shader compiler fails because build ellipsoid. Obviously misspelt it. No. BVH build ellipsoid. Right. This is so the shader's compiled successfully. Now the only thing that which is cool. So this failed now. So I changed the sync resource stuff, and I was quite happy with it because I was able to return a shader index, which is quite cool. I guess we'll just return E32 max is really bad. Do allow implicit syncs to merge. No, do not allow implicit syncs to merge with our explicit syncs. Alright, I missed that. Thank you, compiler. And apparently it worked pretty neat. Oh, I compiled, sorry. Now it's time to test if it works. So if stream dies, we'll be right back, but hopefully it all works. Yeah, let's go. Right, we've got a crash, but thankfully that was an assertion. Right, it's got to be big enough to store at least 2 pointers in it. So, which is kind of, so yeah, we use like 2 pointers worth of memory for a free node. We have a previous and a next pointer. Maybe we should only need enough for 1 pointer if we made them indices. But yeah, so in the object pool, this structure will be reused when it's been deallocated. But hopefully we find some more stuff, you know? Maybe we don't need it. But yeah, we might need like a BVH node type, maybe, to save as a top level, bottom level. But that'll do. Alright, next one. Allocate, whoops. Nodes count must be a multiple of 4, got... Oh. Well. That's the problem with using a U16, isn't it? Because we've used a U16, we can't actually allocate 64k worth of nodes. Big problemo. I did not think that through. But it doesn't matter, we can allocate just under 64. Yeah, it's kind of okay. But yeah, that's definitely an undersight. Not gonna lie. Allocation. Right, here we go. Hopefully this works. And the BVH failed to build? No. Right, so that was it returned false somewhere. So it shouldn't have been there. Oh, if block return false. No, you melon. If block equal null. F. Yeah. Here we go. Hey, machine knob. How's it going? Oh, I got a validation error. Must be in a recording state. Ooh. Oh, crap. I've just realized. Our upload buffer has to be uploaded to... Yeah, see, my upload buffer and read back buffer stuff is a bit silly. Yeah, it's quite alright. We're just temporarily using Z just to give it a bit of a go. We're gonna maybe move on to the Helix editor at the weekend. Yeah, just switching editors around, you know. Oh, integrate terminal. Yeah, you can do like that, isn't it? Oh, wrong one. Yeah, it's down here, isn't it? Oh, yeah. It's weird that the same key doesn't hide it, not gonna lie. That's quite... Maybe you could change that behavior. Zoom in, enhance. It also has Copilot as well, and you can do multiplayer programming. So, the way my upload buffer stuff works is a bit weird. I don't know what I want to do. So I've got two choices now. I can either queue up the fact... I can queue this information up and do it a little bit after. Or change how my GPU layer works. I just got to figure out what is correct way to do it. So the problem is the upload buffer stuff has to be called before. I think it's slightly wrong anyway. I think it's slightly... Yeah, I think it's just incorrect. Yeah, maybe it's time to fix my GPU layer because I... So frame start creates a new command buffer. But yeah, it does the readback start and then... Oh, it's just so dodgy, man. Then a readback end will... Hmm. Yeah, so I think maybe we can draw this up a bit, but so I think what happens is you have your frame start, and you have I'm waiting on SSH inside Z, as most of the stuff is done on the server. Right. What do you mean by SSH? Do you mean like be able to like browse files over SSH? Um, what's the problem currently? Do I double buffer my, yeah, I double buffer my upload buffers and my readback buffers. So I don't know what the issue is, why I have it separated into a separate. It's just a bit bizarre. I think the basic idea is I want to be able to right, I think the primary reason why I did it this way is because I want to be able to upload in the initialization period of yes. So do some uploads in the initialization period of the graphics system. So I think I wanted to be able to use GPU upload outside of frame start and frame end. Oh. So I think what we need to do is move. Yeah, make it so we can only upload in between frame start and frame end, except for when you're booting up the system. Or maybe when you boot up the system, you just do a frame start and frame end, but you just do some uploads. Yeah, I think that's the way to go. Okay. This is quite crazy though, because right, so what I might do temporarily is write the BVH code in two different ways. And then just to make sure that this new code that we've written is fine. And then we'll refactor the GPU system and then the BVH node code. Yep. Because I don't want to do two big changes and then have to test them both at the same time. Because that would just be hell. So yeah, we'll split the nice function we've made into two pieces. So this GPU build from GPU data. I'll just basically make one of them just do the allocation part, and the other one will just do the dispatch. So we'll just put them in two separate sites. Yeah. That's cool. That'll work. Right. Okay, I think we'll save that for next stream. So we'll split that up, get it working, and then we'll correct our upload and read back design, because currently it's wrong. I think if you have very fast frames or if you have very long frames, I forget which way around it is, you'll get a time when the CPU and GPU are right into the same buffer. So it's kind of wrong at the moment. So I want to fix that, and that will help fix not being able to upload and then do some dispatches in the same place. Cool. So our next be on Sunday, 6:30 or 6, whatever, I forget these days. PM GMT +1. We have a YouTube channel where I posted about the BVH node building stuff all on GPU. So if you want to watch that, it's on there. And then there is a Discord where you can come and hang out and chat about things off stream. Throw me your config. You care or not, up to you. Yeah, I was thinking about it more today. Campaign, thank you so much for doing it. But I was thinking about, like, I already have a really heavily modified NeoVim config. And I think now that I'm doing a new editor, I don't want to just copy and paste that config over. I think I want to really rebind the crap out of all my keys with Helix. Because I'm using Colmac, it's going to be all skewed anyway. And I want to build the ultimate one for me. So it's been inspired by my current one, but I'll just redo it. But yeah, so I think I'll take a crack at that on Saturday. Yeah, thank you so much for that. Yeah, I think so. I think I will. I think I actually will like a piece of software, which is kind of interesting. Yeah, I really did love Vim initially for a long time. I went to NeoVim, I didn't really feel any too many improvements, you know. So I think this one will be generally feel like a step up. Oh, excellent. That'd be cool. Yeah. If we get some people working with Helix. Yeah, I think they got that Helix tutor as well, a bit like the Vim tutor, so you can sort of learn within the editor. So that's another thing that's quite helpful. Yeah, exactly. Yeah, it's done a few things by default which I'm a bit weird about. Like if you put your cursor here, you hold control and you press delete, what do you expect it would do? My brain would be like, oh yeah, delete the white space. But no, this thing's like, I'll delete everything up to the end of the next word. I think that's bananas. Even when you do that. You could probably change it in the settings, but default behavior, bananas. You don't get that problem in modal editors because you probably have options to do both things. But yeah. Obviously, that's just a nitpick. But I think that's quite bananas. But yeah. Right, I'm gonna go and hang around with my wife for a minute and then exercise and then go to bed. Oh, I need food. Eat more food. Thank you all for coming, guys. Have a wonderful weekend. I'll see you all at the end of the weekend. Right, I might do that thing where I just don't raid anyone because I have to jam. Thank you so much, guys. Thank you. Right.